We have a question here which says convert the block diagram to a signal flow graph format. First thing you need to do is identify the nodes, which is your RE, Y3, Y2. Your nodes are your system variables. So you identify the nodes um, Y3, Y2, Y1, and your Y. Then you need to draw your branches. Um, we have R going to be the branch. You have E going to Y3. You have Y3 going to Y2. So, so they're all moving forward parts. And you name them. So between your Y3 and Y2, you have G1. Between your Y2 and Y1, you have G2. Between your Y1 and Y, you have G3. And C, we have connection between Y2 and GY. So you draw it's like this. Y2 and Y. This will be your G4. And we have feedback loop from Y to Y2. That's H2 minus H2. This is the minus and you have that feedback from Y1 to Y3. From Y1 to Y3 minus H2 minus H1. So like this, you're done with your signal flow graph. This will be one. That's another example here to construct the signal flow graph for the system described by this equation Y2, Y3, Y4, Y5. So sometimes they might not give you the block diagram, just the equations. To solve this, you have to firstly identify uh, the variables. And your variables are Y1, Y2, Y3, Y4, and Y5. So you try your let's see, three, Y2, Y3, Y4, Y5. Then you draw your branches. So first, for the first equation, we have y2 equals to a1 to y1. A1 2 means it's moving from y1 to y2. A1 to a3 to y3. This signifies that it's moving from y3 to y2. The neutron is moving backwards from y3 to y2. A3 to you have y3 equals to a23 y2. It's moving from y2 to y3. A43 y3. It's moving from y. Sorry, this is meant to be. It's meant to be y4. So it's moving from y4 is moving from Y4 to Y3. Y4 equals to A24 Y2. Moving from Y2 to Y4. Since A24, you have A34 Y3. It's moving from Y3 to Y4. Um, A44 Y4. This is going to be looping on the two. A44. You show them Y5 equals to A25 Y2. It's going to move from Y2 to Y5. Then it's Y2 to Y5. So and you have A45 Y4. It's moving from Y4 to Y5. So this is your signal flow graph for the system. Now, moving on to example 3. Using Mason's gain formula, determine the closed loop transfer function y of x over r of s for the signal flow graph. To solve this, first step is to identify the forward path. Your forward path is moving forward. So your forward path is you have only one forward path, that's r of s to e of s to y of s. Your P1 is particle equals to G of S, which is this. The next step is to identify all individual loop. Individual. So the first thing we have only one loop the system, which is from E of S to Y of S and Y of S back to E of S. Let's move that. Let's try that. So you have one L1 is E of S to Y of S back to E of S. Then the gain, which you want, the gain of your loop will be G of S multiplied by minus HS. Again, G of S to minus H of S will be equals to minus G of S H of S. The next step is to identify non-touching loop. So non-touching loop. These are the loops that are not touching each other. But over here, you have only one loop. So there are no non-touching loop. Uh, so your non-touching loop is zero. Zero non-touching loop. The next step is to calculate the graph determinant. Calculate graph determinant. So so the graph determinant for your first part, this is your first part, okay, is delta 1, it's delta 1, supposed to. Since there are no loop, since all the loops are touching the part 1, your graph determinant will be equal to 1. If, okay, in the next example, we're going to solve we see for where the loops not touching a particular part. Let's calculate total normal determinants. That will be just 1 minus your loop, the loop L1, the 1 minus loop L1 as equals to 1 minus the gain of the minus G S H S will be equals to 1 plus G of S H of S. Now, the formula we're missing, because you actually use missing gain formula. Your missing gain formula C of S equals to P1 delta 1 over your delta total delta. Okay, equals to what's the P1? The P1 is G of S. G of S multiplied by what's the delta 1? 1 plus delta G of S H of S. Therefore, your transfer function will equals to G of S from 1 plus G of S H of S. So this is how you can use your signal flow graph and you can use your missing gain formula to find the transfer function of your signal flow graph. Example 4. Using Mason gain formula, determine the closed loop transfer function y5 over y1 for signal flow graph. So your first step is to identify forward paths. So let's look at the forward paths we have. We have one, yeah, we have another one, we have another one, yeah, we have another one. Yes, that's all. So we have three forward paths. So let's write it down. The diagram is not complete. This is A, 2, 3, 3, and our first forward part, this is mostly forward part. Okay. Our forward parts y1, yeah, y1 to y2 to y3 to y4 to y5. Your gain will be a1 to a3, so the p1 at 1 be a1 to a2 3, a3 4, a4 5. And your next part is y1, y2, then y5, y1 to y2 to to Y5. E2, so your gain will be A1 to A25, A1 to A25. Then your third part will be Y1, Y2, Y4, and Y5. And your gain will be A1 to A24, A45. Let me explain how I got this over again. This one is this a pattern. So Y1, Y2, Y3, Y4, Y5. Your gain equals your A1 to A23, A34, A45. Same thing for the second part. A1 to Y1, Y2, then Y5. And your gain A1 to A25, A1 to A25. Then your third part Y1, Y2, Y4, Y5 from here. And you have your gain A1 to A2, A1 to A24, A45. And let's move to the next step. Next step is identify all individual. Identify. So let's draw it like this. So U and K. Your first loop, let's look at the loop. So a loop, the first loop, we have this going from Y2 to Y3, then back to Y2. And you have another one, Y2 to Y4, then back to Y2. Then you have this other one, a Y4 back to Y4. The reason we are not considering this part as a loop is because of the arrow, see the direction A. So it's not actually going back to Y. So that's why we're not considering it a loop. So our let's write out our loop. So we have first loop Y2, Y3, and Y2. And your gain will be A23 and A32. A23, A1, A23, A32. Then your second loop is Y3, Y4, Y3, Y3, Y4, Y3, Y4, Y3. And your loop will equals to A34, A43. And your last, no, your last one, your other loop is Y2, Y4, Y3, back to your Y2, L3 equals to A24, A43, A32. Let's move this one down. Your last loop is Y4 to Y4. It is L4 equals to A44. That would be okay. I hope you understand this, but that's Y2, Y3, Y is this loop right here. Y2, Y3, Y2. Are you okay? Whatever you say, it's like same thing for this Y3, Y for Y3. It's Y3, Y for Y2. And this Y2, Y3, and Y2, Y for Y3, Y2 is 2, Y4, Y3. So we're using this game. And you may be wondering that for your loop 3, why are we using A24, A43, A32? This is because we're moving from here to here, then A43, A32, and back. So you're not passing through this place. So, so I hope that explains it. The next step, moving on to the next step, is to identify non-touching loop. Identify non-touching. So let's go back and analyze our seconds. Look at our loops. So let me circle our loops. We have loop 1 here, that loop here. We have another loop here. So to speak. Okay. We have another loop here. You know, they ask us to identify the non-touching loops. So how we can know the non-touching loops are if they are sharing the same node. So this loop here is touching this loop. This loop is touching this loop. So the loops that are not touching are this one, this one here, this one. Because they are not sharing the same node. You can see the node here are not touching top. So that's how you identify your non-touching loop. Your non-touching loop for your non-touching loop, you have Y2, Y3, back to Y2, and you have your Y4. So Y4. Let's check that. Y2, Y3, then Y2. In the game, so your loop B, L1 equals to 2, 3, A3, so A4, A4, 4. Then you are meant to um, multiply them together. So your L1 times L4, L1, L4 equals to A23, A23, A32. That's not touching. And the next calculates the graph determinants. So we are going to be calculating the determinants for each part. Calculate for this one. So your delta one. So let's look at this. To calculate, to find the graph determinants, you have to look at the the parts that the amount of loops that are touching the parts. So if all the loops in the signal flow graph are touching the parts, the determinant equals to 1. Let's look at your first part. This is the first part here. You can see from our first part that all the loops are touching. So all the loops are touching it. So that means your delta 1 equals to delta 1 Let's look at the second part. The second part is y1, y2, y5. That's our second part. But see from our second part that you have this loop here, it's not touching it. So, and this loop here. The reason this one I don't pick this because this is touching, these two loops are touching, these two loops here are touching. They're sharing the same note as your parts. So now find your delta. So your delta 2 can be equals to 1 minus. There's going to be in bracket 834 843 plus 844. This will give us 1 minus 834. 1 minus 834, 843 minus 844. Then your third one, that's the third part. Let's take a look at that. So your part 3, that is y1, y2, y4, y5, y1, y2, y4, and y5. You can see that all the loops are touching. Start touching it. So that means your delta 3 equals to 1. So now that we are done with the step, we will now apply our main scene in formula. So your Wi-Fi or Y1 equals to P1 delta 1 plus P2 delta 2 plus P3 delta 3. And the delta. And repeating everything we have. So your P1 is A12, A23, A34, A47. A12, A23, A34, A45 times what's your delta and delta 1 is 1 plus what's the P2? Your P2 is check A12, A25, A12, A25 multiplied by this this name the brackets minus A34, A43 minus A44 plus A12, A24, A45 times 1 times 1. Everything is over. Okay. Just mention your delta equals to 1 minus just sum of that'll be 1 minus L1 plus L2 plus L3 plus L4. You know how to non-touching loop. Your non-touching loops L1 and L4. L4. Let's say that'll be 1 minus A23, A32. What's the L2? A32. Sorry, A34, A43 plus what's the L3? A24, A43, A32 plus what's the L4? A44. Everything plus what's the L1, L4? A23, A32. You can leave it like this or further simplify it. You can multiply with a equals to A12, A23, A34, A45 plus A12, A25 minus A12, A25, A34, A43 minus A12, A25, A44 plus A12, A24, A45. Listen over 1 minus A23, A32 minus A34, A45 minus A24, A43, A32 minus A44 minus A23, A37. This is your transfer function, Y5 over Y1. Okay, so I made a mistake here. Did not finish in the L1, L1, L4. So this is meant to be A44. I'm meant to write A44A. So please take note of that. Yes. And now the answer is correct.